This is the homework helper for Chapter 11, Section 2 in the 7th grade workbook, Experimental Probability. So let's go ahead and take a look at the top part here. They're asking us to find the experimental probability, and not only are we going to write that answer as a fraction, which is really easy to determine, but we're also going to write that answer as a decimal and as a percent. Well, we know how to do that because we've already learned how to change from fractions to decimals to percents this year. To change from a fraction to a decimal, you're going to take and divide the numerator and the denominator. Once you have that decimal, you're going to take and move the decimal 2 times to the right and add a percent sign, and that will be your solution as a percent. So let's look at number 1 here. It says Jacqueline is a soccer goalie. She has 21 out of 25 saves in practice. What is the experimental probability that she will have a save on the next shot on the goal? Well, if she's made 21 out of 25 saves, the probability of her making a save is 21 out of 25. Now we're going to take and divide those numbers to come up with the decimal solution. 21 divided by 25 is going to give me 0.84. So there's a 0.84 chance that she's going to make a save. And we can also go ahead and change that to a percentage and write that as 84%. Let's try that again. If Harris hits the bullseye 3 out of 8 times at archery practice, what is the experimental probability that he will hit the bullseye on the next try? So, if he's hit the bullseye 3 out of 8 times, then the probability of him hitting the bullseye in the next go-around is 3 out of 8. So now we're asked to go ahead and change that to a decimal and into a percentage. Again, to change that into a decimal, you're going to divide. Numerator divided by denominator, 3 divided by 8. 3 divided by 8 is going to change into 0.375. Now you're going to go ahead and move the decimal 2 times to the right and add a percent sign, and that's how we change it to a percent. Well, when I move it 2 times to the right and add a percent sign, I come up with 37.5%. Alright, so with all that out of the way, let's go ahead and scroll down and take a look at some of the problems at the bottom of the page. Question number 5 says, after a movie premiere, 99 of the first 130 people surveyed said they liked the movie. What is the probability that the next person surveyed will say he or she liked the movie? Well, let's look at the question. The question says, based on the results of the survey, the results of the experiment there, that 99 of the 130 people liked the movie. So the experimental probability that somebody's going to like the movie is going to be 99 out of 130. Now the B question, the follow-up, says what is the experimental probability that the next person surveyed will say he or she did not like the movie? Well, these two events are complements. And again, we just defined that in the first section here. Complements describe two events whose total probability is 100% or 1. That's all that can happen. We can either like it or not like it. So everybody else had to have not liked the movie then. So of that 130 people, how many did not like the movie? Well, that would be 31 other people there that, since they didn't say they liked it, means they said they didn't like it. So that's a 31 out of 130 chance that you're going to find somebody who didn't like the movie. All right, one more question. We'll go ahead and take a look at number 7 here. Number 7 says, for the past 4 weeks, Nestor has been recording the daily high temperature. During that time, the high temperature has been below 45 degrees on 20 out of 28 days. What is the experimental probability that the high temperature will be below 45 on the 29th day? So, we've been saying here that there's a 20 out of 28 chance that it's going to be below 45 degrees. So on the next day, it's still a 20 out of 28 chance that it's going to be below 45 degrees on the next day.